January 28th, 2026, Newport News, Virginia. Look closely. This isn't a cruise ship leaving for the Caribbean. This is 100,000 tons of American sovereignty, moving under its own power for the very first time. The tugboats are pulling away. The nuclear heart is beating. The pre-commissioning unit, John F. Kennedy, CVN-79, is navigating the James River, heading for the Atlantic. The media calls this a milestone. I call it a stress test. We are not here to celebrate a launch. We are here to audit a machine. But before we look at the hull, look up. Look at the island, the superstructure. If you know the Gerald R. Ford CVN-78, you know it carries the dual-band radar, flat panels, static faces, futuristic, expensive. Now look at the Kennedy. What do you see on the mast? A spinning bar. That is the ANSPQ-9 Bravo, a rotating radar, mechanical, friction, moving parts. Here's the paradox. Why does the most advanced warship on the planet, a vessel approaching a $13 billion price tag, feature technology that looks like it belongs in the Cold War? Have we run out of money? Did we lose the blueprints for the future? No, we didn't run out of money. We ran out of patience with unnecessary complexity. The first ship, the Ford, was a physics experiment, a floating laboratory. The Kennedy is not an experiment, it is a factory. Its product is violence. And factories do not care about looking futuristic. They care about uptime. Today, Navy Decoded dissects the difference between innovation and reliability. We are going to deconstruct the engineering pivot that saved the Ford class from its own ambition. If you are tired of the media hype and want the raw engineering audit, acknowledge the signal, hit subscribe, lock it in. Now, let's look at the timeline. To understand the machine, you must understand the friction that forged it. This ship is late, painfully late. But the timeline tells you more about the state of American industry than any rivet or weld. Do the math. The first steel for CVN-79 was cut in 2011. The keel was laid in 2015. The current delivery date? March 2027. That is 16 years. Let me put that number on a scale so you can feel the weight of it. World War I lasted 4 years. World War II lasted 6 years. The Manhattan Project, the engineering sprint that unlocked the atom and ended a war, took 4 years. Add them up. 4 plus 6 plus 4. That is 14 years. We have spent more time building one ship than it took our ancestors to fight 2 world wars and invent the atomic bomb. This is the price of ambition. While we were negotiating contracts and debugging software, the enemy was not sleeping. In that same 16-year window, China went from zero to commissioning the Type 003 with electromagnetic catapults. Time is a weapon, and we have been bleeding it. Why does this delay sting? Because of the shadow of the Nimitz. The Nimitz class has served for 5 decades with absolute reliability. It is the workhorse. The Ford class was supposed to be the racehorse, but for years, it refused to run. The successor struggled. The technology was unstable, the elevators didn't lift, the catapults didn't launch. The frustration in Washington became kinetic. Congress raged. The President of the United States famously looked at the cost overruns and technical failures of the electromagnetic systems and suggested we return to steam. Think about that. The political pressure was so high that the Commander-in-Chief wanted to revert to technology from the 1950s. But the engineers held the line. They refused to go back. They chose the hard road. October 29th, 2019. Dry Dock 12, Newport News. The engineers opened the sluice gates. 100 million gallons of water from the James River flooded the basin to lift the hull off the keel blocks. The cameras flashed. The headlines screamed, "Ahead of schedule." The media saw a milestone, but Navy Decoded sees a strategic failure. This was the definition of an illusion of speed. They floated the hull to claim a political win, but the vessel was structurally hollow. By rushing the launch, they committed a cardinal sin of naval engineering. They moved the workspace from a controlled dry dock to a chaotic pier. Instead of finishing the complex cabling and outfitting in a static environment, they forced the workforce to do it on a floating platform. The result? The ship hit the water in 2019, but it didn't move for another 6 years. That is not speed, that is procrastination disguised as progress. They bought a photo op in 2019, and we paid for it with years of delays. You can cheat the schedule, but you cannot cheat the physics. Then came the silence. From 2022 to 2024, the program went dark. Supply chains shattered, skilled labor evaporated. The delivery slipped from 2024 to 2025, then to 2027. But in that silence, the work happened. The infant mortality phase of the technology began to pass. Which brings us to January 28th, 2026. The ship moving under its own power. This is the resurrection. 16 years of friction have not produced a museum piece. They have produced a weapon that has memorized every mistake of its predecessor. Why accept the delay? Why not just build another Nimitz and be done with it? Because the Nimitz is dead. It just doesn't know it yet. Go back to the blueprints. The CVN-21 program, the origin of this class, was not designed to equal the Nimitz. It was designed to kill it. The requirements were physically impossible with 1970s technology. The Navy demanded a sortie generation rate, the speed at which you can launch and recover bombs, increased by 33%. They demanded a crew reduction of 700 sailors. They demanded a reduction in operating costs of $4 billion over the ship's 50-year life. Here is the paradox. To save money in 2070, you have to burn money in 2020. To reduce the crew, you have to increase the complexity of the machines. Automation is not free. It is bought with engineering complexity. That is the trade-off. But the timeline has consequences. The enemy is now purely mathematical. The USS Nimitz, CVN-68, is scheduled to begin deactivation and defueling in 2026. The Kennedy does not arrive until March 2027. Do the math. 11 carriers required by law. 1 retires, 1 is late. That leaves 10, for 12 to 18 months. The United States Navy faces a carrier gap. This means deployments for the remaining ships get longer. Maintenance windows get shorter. The metal fatigues faster. The sailors break down faster. We are borrowing readiness from the future to survive the present. So why not rush the Kennedy out? Why not push it to sea in 2025 and fix it later? Because we tried that with the Ford, and it was a disaster. In 2020, the Navy made a command decision. They switched from 2-phase delivery to single-phase delivery. In the old plan, the ship would have been delivered incomplete, then brought back for upgrades. The new plan? Finish it. All of it. They kept the ship at the pier for 2 extra years. Why? To integrate the F-35C Lightning II right at the factory. The Ford had to go back to the yard to get its deck reinforced for the F-35's heat. The Kennedy is born with it. But there is another ghost in the machine. The MQ-25 Stingray. This is the future. The unmanned tanker. The Kennedy is being configured to handle the drone wing from day one. The electromagnetic catapults and the flexible deck design allow this ship to adapt to a future where pilots are optional. We accepted the gap today to ensure air dominance for the next half-century.